Hello students, how are you? Hope you must have done Kirchhoff's law, meter bridge and other stuff. In today's session we will take up potentiometer. This is another electrical instrument which has got very good significance. In NEET or JEE, questions are usually asked from this topic. This is conceptual, very easy to understand, but yes, you need to be careful. So let us quickly understand what is potentiometer. You must ask me one more thing, that we have a device called voltmeter. Voltmeter also measures potential difference. Why there is a need of potentiometer? If potentiometer is also used to measure the potential difference, as the name suggests, potentiometer you can see on the board, right? So there is a difference. There is a difference. You know that voltmeter has nothing, special in it, whereby it can show the measurements. It can show the measurement while taking current from the circuit itself, whereas potentiometer has its own establishment, own arrangement of current and everything, right? So there is a lack of accuracy in voltmeter, in the measurement of voltmeter. We don't have ideal voltmeter as such. A practical voltmeter would always measure inaccurately. That is lesser than the true value, right? So there is a need of a device which can be used to measure voltmeter, measure potential difference or EMF of cell accurately. So here let us, here we need to introduce this device, and this device has got its own source of electric energy, so it doesn't draw any current from the circuit, circuit for which you are interested in measuring the potential difference. It doesn't draw any current from that circuit, right? It has its own establishment, own arrangement of electrical energy, right? As you can see, the basic rough sketch of potentiometer is this. It has got a variable resistor, which can control the amount of current flowing through the wire. This is important here. AB, length of the wire is AB. This wire is there, right? There is a driving cell. The EMF of the cell is known, fixed for the given potentiometer, right? And if we wish to find out the EMF of a given cell, which is here, this can be connected in this manner. We'll talk about this. Okay, we'll talk about this. As you can see, three things are there. One, it has its own, potentiometer has its own driving cell. We call this cell or battery to be driving cell. It provides current to the, current to the wire. That is there, okay. Then resistor, variable resistor, or rheostat also at times we can say. Rheostat that can control the amount of current. We need to fix the amount of current flowing through this wire AB, right? So, and then there is one key, alright. So this is the basic arrangement of potentiometer. If the cell whose EMF or internal resistance is to be determined, which is the use of potentiometer, that can be connected in this manner. We will talk about this one by one. So let us quickly understand what is it. What is potentiometer? Potentiometer is device used to determine the EMF of cell and internal resistance of the cell accurately, right? Now, what is the principle behind it? Principle is very simple. Just have a look. We know that from Ohm's law, V equals I into R. You are aware of this. V equals I into R. You are aware of this, right? What is here? What is this I here? Current. What is this? Resistance. So if you know that resistance R equals rho L by A. Rho L by A. Now if a wire, potentiometer wire, has specific resistance that is obviously constant. If you have a wire of uniform cross section, then this is fixed, because wire has got some resistivity, and that resistivity you have taken to be constant. So if this is there, if this is constant, so R is proportional to length. So you know what is happening? You are keeping current constant, you are keeping area constant, wire that you have taken at every point, because the same material is being used, resistivity is also same. So in that scenario, what is happening, that V is proportional to L. So this is the basic idea behind it. You know what? We have to find out the potential difference, right? Potential difference or EMF of the cell, right? We have in the wire of the potentiometer potential drop directly proportional to the length, right? This is something that we need to keep in mind. This is the principle of potentiometer, right? So this is something we understood. V is proportional to L. Now what? V equals K into L. What is K here? K is constant of proportionality called potential gradient. What is potential gradient? We'll talk about that. That has got very significance in this particular topic, because questions are asked from potential gradient. They will ask you to find out the potential gradient of a given potentiometer. Based on that, other parameters are also determined. Okay, so is this clear? Potential difference is directly proportional to the length of the wire. When that is there, a potential difference is proportional to length when wire has uniform cross section, point number one, and the area of cross section of the wire is uniform throughout, right? Now let us understand what is potential gradient. So potential gradient is defined as potential difference per unit length. Potential gradient is potential difference per unit length. Okay, now try to understand how to determine the value of potential gradient for a given potentiometer. So how many parameters we need to understand? See, if we have to find out the potential gradient of the potentiometer, this is the simplest arrangement. As you have understood, in potentiometer, one cell is there, one rheostat, and wire of few meters. We will talk about why this few meters, why not only 1 meter. There are 4, 6, 10 meters of length. Wire has got that value. So longer is the wire, potential is more sensitive. If a wire has got longer length, then what? Potentiometer will be more sensitive. That it can measure even the very small value of potential difference. That we will talk about when we will understand what is sensitivity of potentiometer. So right now just pay attention to this, that whatever its length is, length of the potentiometer wire, this AB. Right now here we can consider that, okay, this length of the wire is L, length of potentiometer wire. Length of potentiometer wire. Okay, now you have got R. This R value is this here, series resistance, right? Oh, and now comes resistance of the wire. We are talking about this. the resistance of the wire has got some significance, because when we measure potential drop across the wire, what we are actually intended to consider that potentiometer wire has also some resistance. And one very important aspect of this, one very important feature of the potentiometer wire that we need to consider is it has high resistivity, right? High resistivity, low temperature coefficient of resistivity, right? That means the wire is made up of material which has got smaller value of temperature coefficient of resistivity. That means it should not get affected by the change in temperature. If there would be there would be change in the length due to the temperature change, or change in resistivity of the wire due to the temperature change, then what will happen? The accuracy that is required by this potentiometer, that is what intended to be there, the resistivity will not be same if there is a change in temperature. So we need to keep that value constant. Resistivity value has to be constant. So wire is made up of those material which has which have very small, very negligibly small value of temperature coefficient of resistivity. So we will talk about this. This is important. In boards also questions are asked. In NEET also, you need to, if from theory some question comes, that can be the answer. The constantan and manganese, these two materials are used to make the wire of potentiometer, because those alloys have got smaller value of resistivity, smaller value of temperature coefficient of resistivity. That means they hardly get affected by the change in temperature, right? Their resistivity hardly gets affected by the change in temperature. So that we need to keep in mind. We'll talk about that. So right now our concern is that these are the parameters: R, RW, EMF, RWL, right? So this is what we need to understand. What is RW? This is resistance of the wire. This is resistance of the wire. Resistance of wire, right? So what is this? This is EMF of cell, EMF of driving cell. What is this driving cell? Driving cell is the cell which provides current to the potentiometer. That is very important here, right? When there would be a question on this, you are required to find out the EMF of a given cell, not this cell. This is the part of potentiometer, part of this instrument. This battery is called driving cell at times, right? This is providing the current to the potentiometer wire. Okay, so this is these are the parameters: L, R, RW, EMF. Okay, now we are interested in finding out potential gradient. Potential gradient is what? K equals VA minus VB. VA minus VB by total length. Mind it, this is very important. Potential gradient means potential difference per unit length. Potential difference per unit length, right? Potential difference per unit length. So potential difference of what? Potential difference of the wire. Potential difference across the wire of, wire of potentiometer, right? AB. So VA minus VB by total length of the wire. This wire has got this length, right? Okay, is there any confusion if I put here to be this equal to be I into RW? No, there is no problem, because current flowing in this. This current is I here flowing across the wire. Okay, let it be. Potential difference equals what? According to Ohm's law, V equals I into R. Potential difference across the wire equals current flowing in that into resistance of the wire, that divided by length of the wire, right? Length of the wire. Okay, now as we know that current equals EMF upon total resistance. So EMF upon total resistance. Current equals EMF upon total resistance. If we substitute this here, so what do we get? We will get this arrangement. We will get this value, right? K equals EMF upon total resistance into resistance of the wire per unit length of the wire, right? So this is potential gradient. So let us quickly understand. If we have to quickly find out the potential gradient value of a given potentiometer, let's take this. These are the 2 points A and B, and here there is a battery. Let's call this EMF. It has got some sort of variable resistor. Then there is a key, this. So suppose you are given let's call this 5 volts EMF, and resistor has got RW equals, let's say 450 ohm, and this wire has got RW as 50 ohm, and L is 10 meter, right? 10 meter I have taken. So what would be the potential gradient? What would be the potential gradient value? Once you understand this, then how this is used, you will understand, right? How this is used, you will understand. Okay, so let us quickly find out. K equals what? Again, this 5 driving cell, EMF upon that, EMF upon total resistance value 450 plus 50, right? Into what? Resistance of the wire is 50, length is what? 10. Just calculate this thing, right? It is very easy. 5 by 500 into 50 by 10. What is the value? This gets cancelled. What is there? Then 10, this, right? So what is there? 5 by 100. 5 by 100, that means 0.05 volt per meter. Mind it, what is the unit of potential gradient? SI unit of potential gradient is what? Potential gradient is volt per meter. Okay, you need to be careful. Length of the wire might be given in centimeters, right? So you need to be careful. If you are substituting, for centimeter, then volt per centimeter, that you have to measure. So in the NEET problems, right, questions might be given in terms of, options might be given in terms of volt per centimeter. So you need to be careful. Per centimeter or per meter, that you have to understand. SI unit is volt per meter, that is for sure, right? Okay, so this we have understood. Now think of it, how we are going to use potentiometer for finding out the EMF of a given cell. It is very simple, actually. It is very simple. Suppose you have got this potentiometer. We have got this potentiometer whose potential gradient comes out to be 0.05. Okay? Now what? This potential gradient is known to you. Now you wish to find out the EMF of a given cell. How to find out the EMF of a cell? So let us quickly understand. This is the driving cell. the battery which provides the current to the potentiometer wire, okay, let it be, then this is there, and values I have taken to be same, right, the previous one. This is the potentiometer. Is there any doubt in this? This is the basic arrangement, okay, this is the basic arrangement of the potentiometer. Now suppose there is a battery, there is a cell whose EMF you are interested in finding out. So you connect the positive terminal of the cell. This is important. This is important. As you see that potentiometer has got positive terminal A and this as negative terminal. Okay. In order to find out the potential, in order to find out the EMF of a cell, what you would do, take that cell and connect the positive terminal of the cell with the positive terminal of the potentiometer, right? Now what? You have a galvanometer. Connect the other end of the cell, this, with the galvanometer, right? With the galvanometer, and connect it. There is a jockey connector, right? Galvanometer has got two ends. One end of the galvanometer is connected to the negative of the cell whose EMF is to be determined. This we have taken as 5 volts. We have already taken. This R is 450. We are aware of that. We found value, K value as 0.05 volt per meter, right? This already we have found here. So I am taking the same potentiometer to find out the, determine what? The EMF of cell. Determine EMF of cell. Okay, so this we have understood. Now jockey has, one end is connected to jockey. Now what we are doing, we will slide the jockey from end A towards B until galvanometer shows 0 deflection. So potentiometer has its function based on the null deflection of deflector that we have to understand. So galvanometer must show zero deflection, and that point where it shows 0 deflection is called null point, right? Null point. Okay, here very important significance. Very important significance. Few moments earlier I had told you that potentiometer doesn't draw any current from the circuit. If just compare this, if you have got voltmeter has to measure the value. Voltmeter would measure the value of EMF. Do you think that it will be able to accurately measure the EMF? No. Why? Because it will draw some current from it. To operate itself, voltmeter will draw some current from the cell, and the cell has got some internal resistance, so it will not measure the voltmeter. It will not measure the EMF. It will measure this terminal voltage. This is voltmeter. Mind it, this is very important. Voltmeter will draw current from the cell to operate itself. Hence, it will not provide you the accurate value. Rather, it will provide you the terminal voltage of the cell. If cell has got some internal resistance, so some potential difference will be lost. So not accurate value of EMF you will be obtaining with the help of voltmeter, right? But in potentiometer, this is easy. It doesn't draw any current from the cell. And how we came to know about that? Galvanometer shows zero deflection. Galvanometer shows zero deflection here. At not every point, at particular point, at this point, let's call this point to be C. At this particular point, galvanometer shows zero deflection. That means the system potentiometer has not drawn any current from this cell. Mind it, this is very important. This is very important. This cell is this, whose EMF you are supposed to determine. There is no current flowing from this. How do we come to know? Because galvanometer doesn't show any deflection at this particular point, at null point. This is the beauty of this function of potentiometer. Now what we can do? We can say that VA minus VC must be equal to EMF. VA minus VC, potential drop across the wire, is equal to the EMF of the cell. Now what we can do? We can simply say that EMF of the cell equals, as we have understood, we have understood in what? We have understood here in this. We have understood in this V equals K into L. Potential difference across the wire is equal to K into L. K is what? Potential gradient, right? So this is what we are going to take up. K into L. What we need to understand here, this L we will consider as small l, right? This L is balancing length. L is what? Balancing length. What is this balancing length? The length of the wire from end A to the point where galvanometer shows null deflection. So balancing length is what? Length of the wire from end A to null point. From A to null point. Point C is the null point, right? Point C is null point. Point C is null point. So what we got? EMF we got as K into L. EMF of this cell, we call this E1, okay, let it be, right? E1 equals K into L, right? So K value is known to us. Let us take the values. Let's say L equals, what do you call? In meters you are taking, that was 10. So let's call this 6 meters. Okay? Let's call this 6 meter. Okay. So what is the value of EMF of this cell? The EMF of this cell will be, K value is given to us. We have determined actually 0.05 into 6. So volt per meter into meter is volt, right? So what we are going to get? 0.3 volts. 0.3 volts would be the EMF of this cell. So this is going to be the accurate value, as the potentiometer doesn't draw any current from the cell, and hence when it doesn't draw any current from the cell, so it will, suppose I is 0, when V equals EMF minus 0, that means what? This EMF of the cell will be equal to the terminal potential difference that we got actually. Potential difference equals EMF of the cell. So this is what we need to understand. So what we did, we have understood the function, one of the functions, right? This potentiometer is used to determine internal resistance also. Right now we have understood how to determine the EMF of the cell. Here we had known value of potential gradient we have calculated for this particular potentiometer, right? Known value of potential gradient for this potentiometer. We might not be given the value of potential gradient then what we can do, we can compare the EMF of the two cells. One cell has got known EMF, another cell has unknown EMF. That also we will talk about. So right now what we did, we have understood how to determine the EMF of a cell using potentiometer, and why it is preferable over voltmeter, because voltmeter doesn't give you accurate value. Voltmeter doesn't give you accurate value because it draws some current from the circuit itself, from the cell itself, right? To operate itself, the voltmeter draws current from the cell to operate itself. So it will reflect the lesser value of EMF, right? So that's why this potentiometer is preferable. Okay, now we have to move further to find out how the EMF, to understand how the EMF of a cell, how the EMF of cells, of two cells, are compared. You ask yourself, if you don't know the value of potential gradient, how will you move about? How would you find out the values? So this we have understood, how to determine the potential gradient. Now further, the comparison of EMF of two cells. See, this is the arrangement. Okay, I want you to visualize this properly. You have got a plate sort of stuff, okay, or sheet over which you have to have the wire of 10 meter long, wire, 10 meter long wire you have to take up, right? So on the wire, so 10 meter long, and then putting all the arrangements, cell and other stuff, would be a difficult task. The potentiometer, the size of the potentiometer at least will be, big, that big. So to make it smaller, this few meters, this is 1 meter, this is another meter, wire is cut in such a manner and then arranged. The wire, the same wire, instead of this big wire, then battery and this rheostat value there, and then key, right? Instead of this arrangement is broken in this fashion. This one is remodeled in this manner, just to avoid this. Length of the wire is important, no? Okay, length of the wire is important. We will understand why length of the wire has to be larger. Longer length of the wire would be, potentiometer would be more sensitive, would help us in determining the smaller value of EMF, right? So that we will determine, that we will understand. So right now what we have done, this arrangement, if you see, this arrangement, it is kept here, you can see here, right? This wire is broken into small 1, 2, 3, 4. They're arranged in this manner. Here you have strip, metal strip, here this. So this is connected in this manner. So if you consider this to be zero end, this to be zero end, from here it is 100 centimeter, 1 meter, then from here to here 2 meter, from here to here 3 meter, then from here to here 4 meter. That is how this length of the wire, even longer wire, is arranged in this manner. So don't consider it to be a complicated diagram. This is just the simplification of this bigger diagram, right? So that's how you need to understand. Okay, now let us move further. We are interested in comparing the EMF of two cells. Okay, you may ask me why we are interested in finding out that. Suppose you are given a potentiometer whose potential gradient you are not aware of. What would you do? You will have one cell, connect it, and then find out the EMF of that cell. You know the EMF of that cell. Let's say EMF of 1. When you connect this cell there is a two-way key, right? Then 1 and 3 will get connected, so EMF, this will be operating. Now you get the null point N1 here. You get the null point here, and that null point is L1, and this is K into L1. We have determined how to find out the EMF of the cell. So cell 1 will be this. Cell 2, when you connect cell 2, now connect this 3.3 and 0.2 together, so that you have got the null point at 2. The length will be different. So K into L2. Now what you will do? Get the ratio. K value will be cancelled. So this is your arrangement, right? K value will be cancelled. So if you take the ratio, then you have got this arrangement, right? So any of the two has got known value, then it is easy, because L1, L2 is known to you. E1 is known to you. E2 you can determine. So this tool, this approach is used easily. This approach is used to find out the unknown EMF, even though you don't know the value of potential gradient of the potentiometer, right? So for today, this was the thing which we had to understand. In the next session, we will talk about how to determine the internal resistance of a cell, and there are multiple other things like sensitivity of potentiometer, how sensitivity of potentiometer is affected, right? And there are other questions based on NEET and board, right? Okay, so till then, whatever you have understood, practice it properly, and we will learn other things in the next session. Thanks a lot.